Welcome and hello. This is a video exercise using the FHWA hydraulic toolbox, specifically the curb and gutter calculator. And what we're going to be doing is comparing inlet grate efficiencies. So what I have on the screen here is the problem statement. We're trying to find the most efficient grate, and our three choices are down below, 1, 2, and 3. There's three different grate types and dimensions, so we'll be using this information in the calculator. And then up above, we have some more information, such as the slope of the road and the side slope, the longitudinal slope, the side slope, the gutter width, Manning's N roughness coefficient, and the top width T. Okay. So if you want to follow along and use these numbers, I'm going to just move them off to the side here. And let's get started here with the hydraulic toolbox. I'm going to click on my project and then right click, add new curb and gutter analysis. This is the calculator that we want. And then double click to open up the calculator. So now it's a matter of inputting the data and figuring out what is the efficiency for those three different types of grate inlets. All right, so let's start with the longitudinal slope of the road. We were given this as 4%, so 0.04. The cross slope pavement is 0.025, that's 2.5%. Now, we weren't given any information about a separate cross slope just for the gutter, so we're just going to leave that blank. Manning's N roughness coefficient, we were given a 0.016, and the gutter width was 2 feet. Okay, so that's good. Now, we weren't provided the flow rate, but we did have the top width of spread, and that is set to 9.84 feet across. And then you can click on this compute unknown, and that will give us our flow rate of 6.653 cubic feet per second. And then a few other calculated parameters down below. Okay, so that is it for the gutter data. We won't have to change that again. Moving over here to the right half of the dialog box, this is the inlet data. So let's get started. Inlet location, it's going to be on grade, not a sag. As for the inlet type, it's going to be a grate, which is the first of the 5 options here. So let's just go with that. All right, so now we're ready to start going through our 3 different options. This is sort of what we're going to be changing for testing the efficiency. So the first one was P178-4. So that is this grate right here. And then the dimensions were a width of 2 feet and a length of 2 feet. So this one is a square grate. All right. So let's go ahead and click on compute inlet data. And now down below here, we have the efficiency of 0.442. That's 44.2% intercepted of the total flow. Our total flow is 6.653 CFS. What was intercepted is 2.94. What bypassed was 3.71. Cool. So I'm going to write that down in my notes over here. Next up is reticuline. That's the second type of grate that we're going to be evaluating. So yeah, keep with grate. And then scroll down to the bottom, reticuline. Now the dimensions here is 2 foot by 4 foot. So 2 by 4. If you're ever confused about the grate width or the grate length, I've had an error message in the past when the grate width exceeds the gutter width. But okay, so anyway, let's switch that to 2 and 4. Sorry, that's what I had. And go ahead and click on compute inlet data. Here's our data down below here. Looks like the efficiency is increased to 0.541. That's 54% capture efficiency. So we'll go ahead and mark that down in my results. All right, so the third and final grate inlet, so that's grate still, of course, is going to be called curved vein. And then the dimensions are 2 foot by 3 foot. So there we go. Click on compute inlet data and 50.3%, 0.503. All right. So I believe reticuline was the best or the most efficient. Here's the problem statement up again. And then here are our results. The far right column of this table has the efficiency. And then reticuline is the most efficient, as I've labeled right there, at 54.1%. All right, just as a follow-up question to this exercise, I've prepared this question. To the nearest 6 inches, how long would the reticuline grate need to be to achieve 60%, 70%, and 80% efficiency? So right now at 2x4, we're looking at 54.1% efficiency, or 0.541. but how long would that grate need to be? Longer than 4 feet, of course, to achieve these higher efficiencies, assuming that we stick with a 2-foot width for that grate inlet. All right, so back to the calculator. I need to change the grate type back to reticuline and then grate. That's good. So 2 by 4 is where we left off. That's 54.1%. All right, so let's just increase the length to something else, 4.5. So adding 6 inches, because that was the specified length requirement every 6 inches. We're up to 56.3%. Let's go to 5 feet and 58.5. It's got to be 5.5. 5.5 grate length and compute inlet. And boom, there we are, 60.8% with that grate inlet being 2 by 5.5 feet. All right, so that's 60%. Next up is 70%. In fact, instead of just jumping up 6 inches at a time, I'm just going to go straight to 2 by 8. So 8 feet in length and compute. All right, so 71.7%. That is efficient enough, but let's check the next size down, which would be 7.5 feet and compute inlet data, and that is barely less than 70%. So what I guessed first at 8 feet length is correct for achieving at least 70% efficiency. All right, and the last one is 80% efficiency. So let's just jump up to 10 feet. I'm just throwing it out there. Compute. All right, so 78.6%. We're not quite to 80% efficiency. Let's go, just jump up 6 more inches, 10.5 foot length, and compute inlet data. Exactly 80% efficient. So 10.5 feet is the length to achieve that efficiency, given these better dimensions and the design flow. Here is that same follow-up question statement. And then my last slide here shows the results to that follow-up question statement, where we have the grate to reticuline, and then the dimensions that achieve 60%, 70%, and 80% are right here. 5.5 length, 8 foot length, and 10.5 foot length. All right, well, that's it for this exercise. We talked about inlet grate efficiencies. We compared 3 different grates and different sizes for their efficiency. And then the follow-up question asked us to determine the length of the winning grate to achieve these specified efficiencies.